Okay, so we got a question right here. A charge of minus 4.5 nanocoulombs is placed 4 centimeter from X. Calculate the magnitude of force acting on this charge due to the charge at X. So we know that magnitude means just the value. You're not required to put positive or negative. You can just basically say just write the value as your final answer, right? So we have been given the charge of X as well, which is 7 nanocoulombs, right? So I'm gonna write this formula, right? Because this is the Coulomb's law formula, right? And you might be wondering why I wrote the Coulomb's law formula. It is F is equals to Q1 times Q2 times K. K is basically 1 by 4 pi times permittivity of space, right? The K value is given at the end of your basically your exam, paper. So, and you have R square, right? So why I use this formula? Because see, the magnitude of force can be only calculated using this formula between the two charges, right? The X charge and the charge that is placed further away from the X, right? So you need to calculate the force between them, right? So only this formula can let you know the magnitude of the force that is acting on this charge, on the charge, that will be minus 4.5 nanocoulombs. And remember, nano means basically 10 raised to power minus 9, right? Remember that. So let's input the values that have been given in the question. Q1 basically is our 4.5 times 10 raised to power minus 9, right? It doesn't matter wherever you put. You can put it this as Q2 or Q1. It doesn't matter, right? So now you have Q2 as 7 times 10 raised to power minus 9, right? And then you multiply with the K value, which is given at the end of your exam paper, which is 8.99 times 10 raised to power 9, right? And then you divide by the radius. Now we see that the radius is given in centimeter. We have to convert it in meters, so we are going to basically divide it by 100, right, to convert it into meters, right? And then you have to square it because of the formula R square, right? So you have done the squaring, right? You get your F value basically as minus 1.7699, right? And 10 raised to power 14 minus 14, right? So if you round it off, I can see that the values that have been given in the question is 1 decimal place. So I'm going to write my answer in 1 decimal place, right? So I'm negative 1.8 times 10 raised to power minus 14, right? So this is my magnitude of force. You're not required to put a minus as your final answer because ask for the magnitude, but it's up to you. You can write it or not write it, it's completely up to you because it asks for the magnitude, right? That's why you can see in the mark scheme basically they write brackets across these signs, positive or negative, right? Because they did not ask basically the force, they asked the magnitude of force, right? They didn't ask the normal force, either it's positive or negative. They asked for the magnitude only, right? So yeah, this is the answer.